Okay, let us look at this question, a very standard and simple question. This is also MSQ. So, let us take this MSQ from operating system. Which of the following standard C library functions given are library functions will always, look at this, the keyword is always, associate a system call when executed from a single threaded process in a Unix or operating system environment. So, always and in Unix. So, sleep is basically to allow the process to get blocked. Blocking the process is never in the hands of the user, right. So, we have to take the support of operating system. So, therefore, this will always generate a system call. Malloc. See, malloc is basically for dynamic memory allocation. We have the characteristic in the literature of Unix and Linux that whenever malloc requires a large chunk of memory, system call is always generated. But when it requires small chunks of memory, then what happens is it will not generate system call for every memory allocation, but rather for the first time, even the memory allocation needed is less, for the first time it will allocate a large chunk so that it can keep it, and later for subsequent calls of malloc to avoid the wastage of overhead of system call, it will not make or activate system call, but rather from the large chunk that it got allocated, it will allocate memory for the subsequent mallocs. So, that is what is happened. So, therefore, this is not correct. Always is incorrect. First time yes, sometime yes, but not always. String length is a normal user level defined function, therefore, this also will not generate a system call. Exit for for terminating the program has to be done through operating system support. So, this will also generate a system call, will be associated with a system call. So, therefore, the correct answer is sleep and exit, sleep and exit. Okay. Now, look at this code from semaphores. S is a semaphore initialized to 5, counting semaphore initialized to 5, S is initialized to 5 in line number 2 here, and counter is a shared variable initialized to 0, counter is initialized to 0, please observe. Assume that the increment operation in line 7 is not atomic, means preemptive, preemption can happen. Okay. So, in the entry section we are performing 2 wait operations, and then in the exit option we are performing section we are performing 2 signal operations. Okay. So, right, remember this is counting semaphore initialized to 5, every wait will not get blocked, okay, every wait may not get blocked, 5 times I can perform wait operation successfully. So, what happens now, if 5 threads execute, there are 5 threads, 5 processes execute the function parop concurrently, which of the following behavior is or are correct? MSQ. The moment I say is or are, MSQ. There is a deadlock involving all the threads. So many times we have seen in our lectures the deadlock may happen with this, we demonstrated, again I am demonstrating, please follow. If I start with P1 execute wait on S, success, value become 4, preempt, start P2 value become 3, preempt. So, if I allow every process to execute the first statement, all of them, right. So, now the value of S become 5 because all 5 processes have executed that. Then when I start the 6th process wait on, now it will perform wait on a second block, second process block. So, all processes can get blocked, deadlock can very well happen, we have proved that so many times in the classes. So, therefore, deadlock is possible. The value of counter is 5 after all the threads successfully complete the execution of parop. If I execute counter plus plus without any preemption, individually one by each thread, individually one by each thread, then counter first thread will be made 1 by first, then 2 by second, 3 by third thread, 4 by fourth thread, 5th by 5th thread. So, sequentially without preemption, if I execute this code, very well the counter can be 5. So, therefore, very well this answer is also correct. Got it? Now, third, the value of counter is 1 after all the threads successfully complete. Is it possible? Yes, with preemption that is possible. So many times we discuss in the class. How? Preemptive execution. Remember, counter incrementation is actually counter is equal to counter plus 1 will require instructions like load, add, store. So, one thread if it get preempted before store and after that you complete all the threads and allow the first thread to execute store, it will store 1, from 0 it will store 1, as simple as that. The final value can also be 1, this is also correct, this is also correct. The value of counter is 0, 0 can never be possible, we have seen that so much, that is the fundamental point. So, 0 is never possible. So, therefore, the correct answer is ABC, alright. The correct answer for this problem is ABC of MSQ, good. Now, look at this direct problem. The 3 processes arrive at time 0 with burst times of 16, 20 and 10. So, 3 processes, I will write process number, arrival time, burst time 1, 2, 3, 0, 0, 0, 16, 20, 10, 16, 20, 10. Okay. Minimum average waiting time. Minimum average waiting time is possible with SJF, non-preemptive. He is also saying non-preemptive. Is how much? NAT question. Very straightforward. Prepare the Gantt chart using SJF. CPU. So, first P3, 10, then P1, 26, then P2, 46. That is it. Find the waiting times. Come on. Waiting time of P1 is 10. What is waiting time of P2? P2, so 26. What is waiting time of P3? From the Gantt chart, 0. So 36. Total waiting time. It's asking average waiting time. So 36 divided by 3, 12. That's it. Straight away. Okay. In the context of operating system, which of the following statement is or are correct with respect to paging? MSQ. Is or are. Page size has no impact on internal fragmentation. No, page size will have internal fragmentation. With paging, page size, last page may have internal fragmentation. No is false. Paging helps solve the issue of external fragmentation. Primarily, that is objective of paging. Paging overcomes the problem of external fragmentation. Paging has been designed to overcome the problem of external fragmentation. Paging incurs memory overheads in the form of page table. Very true. Multi-level paging is necessary to support pages of different size. In a vague statement, that is incorrect. So, therefore, the correct options are B and C. B and C are the correct options for this. Okay. Let us read this question related in synchronization. Consider the following multi-threaded code segment in a mix of C and pseudo code invoked by 2 processes P1 and P2, and each of the processes spans 2 threads T1 and T2. So, P1 spawns T1, P2 spawns T2, something like that. Okay. The global variable by name X, X is global, kindly observe that, X is global. There is a lock like semaphore, binary lock, binary semaphore. Create a thread to execute foo, so thread T1, create a thread to execute foo, 2 threads are created here, 2 threads. Wait for the 2 threads to finish, so here we are waiting. After both the threads complete their execution, please pay attention, after both the threads complete their execution, then only I print X, then only we print X. So, X is not printed by thread 1 completion and then or thread 2 completion. See, any of both the threads may complete in a different order. So, then we have the function foo, where I have local variable y, this is local. So, both the threads will have their local copies of y, both the threads will have their local copies of y. Please remember, X is shared by both the threads, y is not shared, X is shared, y is not shared. Acquire the lock here is like down operation, then we have this some critical section, then release the lock, this is like up operation, then print y, then print y. So, both the threads will print y, please, both the threads will print y. So, what is going to happen? Y is local. So, thread T1 independently update y from 0 to 1. Thread 2 will independently update y from, because each thread will maintain local copies of y. So, both the initial values will be 0. So, both of them will make it to y 1. Both of them will make it to 1. So, both the threads will print the values of y as 1s. Alright. And then when both the threads, so X is incremented by 2 times, 2 threads, 1 and 2, T1 and T2. So, X will be 2. So, when both the threads finish their execution and print X, X will be 2. So, both threads will print X as 2 and then both threads will print individually Y as 1. I hope you get my point. So, now that is what is the option. Which of the following? MSQ question please. Both T1 and T2 in both the processes will print the value of y as 1 because y is local. So, therefore, this is true. Both P1 and P2 will print the value of x as final value of x as 2 because x is shared. So, therefore, this is also true. Naturally, this is false because at least one of the threads will print y as 2. No, y will never become 2, but at least one of P1 and P2 will print the value, x will never become 4. So, therefore, the correct answer is A and B. That is it. Which of the following statement is or are? Again MSQ. So many questions in MSQ in operating systems are correct in the context of CPU scheduling. The goal of CPU scheduling, is it to maximize CPU utilization and minimize throughput? No, both are same. Maximizing CPU utilization will result in maximization of throughput. Contradictory statement, false. Turnaround time naturally includes waiting time, correct by definition. Implementing preemptive scheduling needs hardware support in the form of timer like, so therefore this is also true. Round robin policy can be used even if you do not know the CPU time a priori, right. CPU burst times by the processes are not known a priori, so therefore this is also true. So, B, C and D straightforward are correct answers. Got it? Very simple. Okay. Now, look at this problem. Consider a computer system with multiple shared resource type with one instance. So, every resource has only one instance per resource type. Each instance can be owned by only one process at a time. Owning and freeing of resources is done by lock again. The following scheme is used to own a resource instance. So, this is a function of acquiring the lock. Look at this function own resource R. Acquire the lock, global lock like semaphore. Look at this, if resource is available then acquire it and then release the lock because I got the resource. Else if R is owned by another process, if resource is not free, then what is going to happen? We are not going to release the lock. So, if R is not free, then in that case what we are saying, terminate the process, kill the process who is owning the resource because I am higher priority, that is what is the meaning. So, after releasing all resources owned by P, okay. So, here again we are saying if R is available, we have not acquired the resource, right. So, a resource is not available. So, therefore, what we are saying, kill the process who is owning the resource after preempting all its resources and then acquire R, take the resource R, okay. Then restart P, P will have to, the process which got killed will have to be restarted, then release lock L, then because I got the resource, so therefore release it, release the lock because I am the owner of the resource now, right. So, this is the code. Then MSQ again. Which of the following choices about the above scheme is or are correct? This scheme ensures that deadlocks will not occur. Whenever we are killing the process, that is a global strategy we have seen in deadlocks, that deadlocks chapter and that too deadlock detection and recovery. When process is getting killed, then actually deadlock can never happen. So, that is what it is saying. So, therefore, this is correct. This scheme violates the mutual exclusion. Mutual exclusion property is very well guaranteed here because we are acquiring the lock and releasing the lock before for acquiring the resource. So, therefore, violates the mutual exclusion property is incorrect. So, it guarantees. It may lead to live lock. What is live lock? In deadlock, the processes will be in block state continuously for infinite time. In live lock, the processes will not be blocked, but rather ready or running state, and then they are waiting on each other and violating their progress for their further progress. Okay. So, may lead to live lock here. Yes, quite possible because if a process is repeatedly getting killed and then that process will kill the other process. So, they will be in a live lock situation. So, therefore, this is also quite possible. May lead to starvation. Yes, if a process is repeatedly getting killed and then it may not get completed, so it may starve to complete its execution. So, therefore, starvation would also happen with this. So, therefore, the correct options for this is A, C, D. B is incorrect. So, that is the answer for this question. Okay. Now, look at this problem. Consider a 3-level paging, multi-level paging, 3-level. To translate a 39-bit virtual address to a physical address as shown. So, 9 bits are used for accessing OPT, then 9 bits are used for accessing next level page table, then the last level page, 3 levels, and then finally the page offset. Finally, the page offset. Page size is 4 KB, 1 KB is 1024, 2 per 10. Page table entry size at every level is 8 bytes PTE, right, is 8 bytes. A process P is currently using 2 GB, look at that, virtual memory which is mapped to a 2 GB. See here, virtual memory size and physical memory size are same, that is the characteristic of this problem. Then there is a NAT question. the minimum amount of memory, NAT question, minimum amount of memory required for page table, all the levels of page tables, right, all the levels of page table, what is the minimum amount of memory needed, that is the question here, that is the question here. So, how are we going to work out this, what is the approach of solving this problem, okay. So, we have to work out here. So, let us see. So, it is advisable that before looking into the solution, you should give a try working out this problem, that will be an interesting exercise. I will slightly move here, maybe my image may get cut, but I do not have any space to write, I will write it down here, okay, bear with me. So, what is page size? So, let us write it here. Let me select the pen, okay. So, I am slightly moving away from the frame, kindly bear with me. What is page size? 4 KB. I will do it independently. If I go for one level paging, just one level, right, what will be the page table size PTS? 2 power 31 2 GB divided by page size 2 power 12, right, 2 power 12. So, what is this value? 2 power 19. These are number of pages, number of entries. What is entry size? So, here I will write page table entry size 8 bytes. So, therefore, page table size in bytes become 2 power 19 into 8 bytes 2 power 3, which is 2 power 22 bytes. This would have been my page table size if I would have gone for one level paging. If I would have gone for one level paging, this would have been my page table size 4 MB, 4 MB. Now, when I go for two level paging, so this is over, I will write with the different ink, okay. If I go for now 2 level paging, I am going for paging on this 2 level. Then what is going to happen? This 2 power 22 bytes. So, how many pages will I get? Number of pages 2 power 22, which is actually including the entry size, please, including the entry size, divided by 4 KB, 2 power 12, 2 power 10. So, either you can do this way, or maybe you can divide 2 power 19 divided by 2 power 9, the offset which is needed for this 9 bits offset, this second 9 bits offset, okay, directly you can use. So, 2 power 19 by 2 power 9, 2 power 10, or 2 power 22 divided by 2 power 12. Why I am saying? Because here I am taking the whole page size. I am assuming every level of paging, the page size is 2 power 12. So, that is why I am considering. So, I am repeatedly saying you can divide either this way, or you can say 2 power 19 divided by 2 power 9, which is essentially same. So, that means at the first level, when I go for 2 level paging, and the number of page tables that I get, inner page table that I get are 1K. So, all these 1K pages of the page table, which are called inner page tables, must be present in memory. So, first with 2 level paging, I got this 1K pages must be there, each of size 4 KB, because every page is of size 4 KB. How 4 KB? 2 power 9 into 2 power 8, 2 power 3, 8 bytes is the page table entry. So, therefore, 1K over 2 level paging. Now, when I go for 3 level paging, what happens? Let us see. Let us see now 3 level paging. Okay. So, what is the size of the page table? So, these are number of entries. So, what is the page table size that I would have got? 2 power 10 into 2 power 3, because these many pages are there, those many entries multiplied by entry size 2 power 3. So, this has to be divided by again 2 power 12, which is equal to just 2 power 13 by 2 power 12, 2 power 1, 2 pages. Right, the page table at the second level get divided into 2 pages. So, 1K pages plus 2 pages at the second level when I go for 3 level paging, got it. So, this is the page table size divided into pages of size 2 power 12, or you would have done like, for example, 2 power 10 by 2 power 9, 9 bits are used to index into this, 9 bits are used to index into this. So, 2 power 10 by 2 power 9. So, actually this 2 power 12 is nothing but 2 power 9 into 2 power 3, that is what I am saying. You getting my point? Page table entry size, number of entries are 2 power 9. So, either, so therefore 2 power 3 anyway is constant here. So, 2 power 10 by 2 power 9 or 2 power 13 by 2 power 12, either way it is 2 pages. So, I need 2 pages of the second level page table. Now, to third level page table. Now, to access these 2 pages I need OPT, the outermost page table, which is called page directory, which is called page directory. So, this will have only 2 entries to access these 2 pages, 2 entries. But how many bits are used to access that? 9 bits, top level, 9 bits. Mean the size of this is also 4 KB. The size of all these pages are 4 KB, please. So, that means the number of pages which are to be present in the main memory for accessing the address space of the process is 1K pages of the first level page table, 2 pages of the second level page table, plus 1 OPT. These are the total number of pages, each of size 4 KB, each of size 4 KB. So, what is this value? 1024 plus 3, 1027, 1027 into 4 KB. So, therefore, because he is asking the answer in terms of kilobytes, so into 4 kilobytes. So, what is this value? 1027 into 4, 4 7 are 28, 2, 4 2 are 8, 9, 10, 1, 4108 kilobytes. So, because he is asking in kilobytes, the value is 4108. That is it. That is the approach of solving this problem. Okay.